Hey there everyone, my name is Chantel and welcome to this Riviera-PRO video where I'll be going over the post-simulation debug feature. With this feature, the simulation kernel isn't in use and allows for observing simulation results after a simulation session has finished using a simulation database file. Being able to analyze simulation results after a simulation run is really helpful if you want to compare simulation results or view simulation results after doing a batch of simulation runs, where you can read the values of recorded objects at different simulation times. So with that little intro out of the way, I'm going to demonstrate post-simulation debug with an example design. I have this Riviera-PRO example workspace opened called Hex2Bin. This is a mixed language design where I'll be using the Verilog version mixed with System C. You can find this example design in Riviera-PRO's example folder under Mixed Language. You can also see in the file system of the example that I have no simulation database file yet. So to get our simulation database file, we'll need to run a simulation. This example comes with a macro for each mixed design. In my case, I'll be using Project RunMe Verilog. In this macro, we have commands that source procedures and variables, open up the workspace, set the active design, set workspace configuration, and then we get to the compiling, initialization, adding and logging signals, and running the simulation. Unlike Active HDL, Riviera-PRO does not have a distinct post-simulation debug setting or license feature. So when it comes to getting simulation data for post-simulation debug, commands for logging signals or adding signals to waveforms is crucial. If you do not add signals by logging or by adding them to the waveform, those signals will not have their simulation results saved. As you can see, this example design has its own procedure.do file and uses this procedure called logger waveports, where it opens up the waveform viewer in GUI mode and adds the objects to that waveform. In this case, it's adding signals contained in this variable, signal list. This variable is inside of the example design's variable.do file, and we can see that signal list is set with all the signals from SCU of the top level module. Another way to log or add signals to the waveform is by using the log or wave command, respectively. I'll be using the log command to log signals for all of the Riviera-TB signals. And one more thing before running the macro, I'm going to go to Preferences, and then Dataset under Simulation, and I'm going to enable Show Event Source since that's one of the things you can do in post-simulation debug mode. Click Apply, then OK. If you already did all the things the macro does, you can just initialize the simulation yourself by going to Simulation, Initialize Simulation, and select Riviera-TB as your top level. Then from there, just use the log command on the console, or use the waveform viewer to add your signals to record their simulation data. I'll go ahead and switch to Debug Perspective and run the macro. Since I've added the log command into the macro, the simulation results that will be recorded after ending simulation will include the signals from SCU, as we saw from the variables file, and the top level Riviera-TB. And here are the simulation results. While simulation is still active, if you go to Help and then License Diagnostics, you will see in the list of license features that the System C simulation and Verilog simulation features are both checked out. And when we go back to the File System tab in the default perspective, there's now a dataset.asdb file. This is the default ALDEX simulation database file that gets saved after a simulation run. This same file is also seen in the Datasets tab. This tab is where all the ASDB dataset files added are listed. Now I'll end the simulation to save my simulation results. Notice now there's no more datasets in the Dataset tab. And now we can go into post-simulation debug mode. Like I mentioned earlier, Riviera-PRO does not have a way to specifically initialize post-simulation debug mode, but getting to this mode isn't that complicated. All that needs to be done is to go to the Datasets tab, right-click, and click Add. From here, add your ASDB file, and now we can do post-simulation debug. And I just want to point out that after the dataset has been added, going back to the license diagnostic, neither the Verilog simulation nor System-C simulation features are in use, which signifies that we are in fact in post-simulation debug mode. I will point out that there are some limitations to this mode. You can't step through code, nor can you set breakpoints. Setting a breakpoint gives a warning where it's unable to access the simulator. Objects created during simulation runtime are also not recorded. And some tools that do require the simulation to be active are not accessible, like processes, call stack, locals, drivers and readers, and data flow. But now let's go ahead and talk about what we can do in post-simulation debug mode. Notice that with the dataset added, the hierarchy window is updated. When clicking on items in the hierarchy window, you can see that the objects window underneath changes to reflect the objects that are within the selected module. Since we recorded data for SCU and HexRAMTB, there's recorded values next to the objects in the objects list. But if I click on U1 or U2, their objects show no data as their value. This happens because I did not log or add these signals to the waveform during simulation. And now with the logged signals, I can add them into the waveform window, the watch window, and the memory viewer. I can use the waveform cursor to move through simulation time, and you could see the watch window and the objects window update at the same time. You can also use the simulation time box to set the debugging time. In the memory viewer, as I increase the debugging time, the value of data changes to reflect the debugging time that was set in the simulation time box. And remember earlier, before getting my simulation data, I enabled Show Event Source in my preferences. So now you can show event source in post-simulation debug mode by using the waveform viewer, moving the cursor over to an event on a signal, right-click, and click on Show Event Source. And this will take you to the HDL editor and indicate the event source in the code. One last thing I'd like to mention about post-simulation debug mode is that you can display signals from multiple simulations. As long as you add the ASDB file into the dataset window, you can access that simulation database's signals and display them on the waveform viewer or any of the other usable windows in post-simulation debug mode. This is especially helpful if you run a batch of simulations and want to compare results or analyze them. And that wraps up this demonstration on post-simulation debug mode in Riviera-PRO. Being able to analyze simulation data without the simulation kernel being active is a helpful feature for debugging designs. This also makes sharing your simulation data with others doable, allowing for a team to collectively look at simulation results. Whether you're doing that, analyzing results in a waveform, or looking at multiple simulation results, Riviera-PRO's post-simulation debug feature lets you do it all. Thank you for watching.